Yeah, good morning, guys, and welcome to this class. Well, this is specially a class designed for the MIT Saturday Python class, and you guys were to have a class with me, but again, physically, but again, we had to do this virtual. And so today, I would like to dive into object-oriented programming using Python. And specifically, I would like us to dive into understanding what classes are and what objects are. And so quickly, let me just launch, let me share my screen, and let me just launch my PyCharm. Quickly, yeah, here is my PyCharm. And so let's just quickly understand. Sorry for these. I have a lot of stuffs here. So now let's just create a new project. And I know you guys have been working on a project already. And so you can also just close that and let's create a new project. And let's call this a Saturday Python OOP. OOP stands for Object-Oriented Programming. Yeah. And so quickly, let's just hit on create. Give it a few seconds and this should be created in a few. Yeah, I know your file or your project is going to be created, and definitely with this basic main.py file that I really don't need the code that is here. I'm just going to select everything here, and I'm just removing it right there because I really don't want to work with that code. And so in this class, just as I've said, we are going to start looking at how to work with classes and objects. And so let me just try to explain what a class is and what an object is. So in basics of it all, or in a layman's language, I would say a class is a blueprint of an object. Now, this is what I mean. Let's go to the very basics of it all as well. Now, assuming today you wanted to construct a house, let's just imagine this is perhaps out of class, yeah? You wanted to construct a house. I'm very sure if you wanted to construct a house, you are gonna contract some architect somewhere. Maybe the guy is gonna draw you a plan. So now what is going to be on the plan is perhaps how wide are the corridors, how big are the windows, as a matter of fact, how many windows are there to be on the house, what are the roofing material, the flooring material, which color for the doors. All those details need to be on the plan. Yeah. And so if you hired an engineer now to construct a house for you using that particular plan, yeah, if that engineer omitted anything on that plan, you wouldn't even sit, it wouldn't sit right with you. Perhaps you may even press charges in court or something like that. Yeah. And so that's exactly what a class is going to be here. Yeah. So your plan, the plan of the house, if someone is going to use that plan to construct a house, then we can say your plan has all along been the blueprint of your house. That means, your house was meant to look like that. Yeah. And so when we say it is a blueprint, it means someone can look on your plan and they can construct a house. And so in this class, we just want to understand the concept of how to have a class. And once we have that class, we can, as a matter of fact, use that class in creating objects. And in this case now, in the example of your plan of a house, then the house you're going to construct out of this plan is what we are now calling the object itself. Yeah. And you can actually use the same plan to construct 50 houses. And all those 50 houses are going to be coming from this one class. And the 50 houses are going to be your objects, okay? So now quickly, for us to understand that concept, let's just create a new Python file. Let's call it as classes so that now when we come to the main.py, we can try to use those classes. So let me just call this as classes. Yep. But of course, you can't name this file as class because the name class is a keyword. The name class is a keyword in Python. So you must just call it as classes like that. And so now to define a class, yeah, to define a class in Python, you just need to start with the keyword class. Yeah, you see, I told you it's already a keyword, class. And so now you need to state the name of the class. Let's assume we are creating a class for a fruit. Yeah. And if we are creating a class so that we can get fruits out of this class, remember, this is the convention. The class name starts with a capital letter. Yeah, capital letter. And yeah, the class name starts with a capital letter. And if we are creating a class to get fruits out of it, the name of the class is in singular. So it is going to be fruit class like that. And so this fruit class needs to have what we call a constructor. So now the constructor is what defines what needs to be on this class. I mean, the constructor is what defines what a fruit looks like. As a matter of fact, let me comment and say this is a constructor. A construct. This is a constructor. Okay, one tab for indentation. Yeah. So so to define a constructor, we just we create an init. We define def init function. And by the way, I have seen students make a mistake and calling this int like that, which is wrong. I mean, it is init. Yeah. So that now here on the init, we can now say what properties of the fruit are. So I can just put a comma and say now, a fruit can have a name, a fruit can have a size, a fruit can have a color, a fruit can have a price, maybe. So those are the properties of a fruit. And someone is wondering, what is this keyword self? So the keyword self is the only entry point through which we can access these properties on a class. That means the syntax of how to create a class in Python, for it to have a constructor or even a method on a class, we need to include this keyword self, because this is the only word through which we can access these properties. And so now, once we have this function, constructor function, so now for these properties, name, size, color, and price to be accessible, we can even just say now self.name equals to name, self dot size, size equals to size, self dot, let me just copy and paste, self dot this equals to this, and self dot price as well, and self dot price equals to price, like that. Self dot price equals to price. And that's it. I mean, as a matter of fact, that's it with this class. This class is already complete. So that now if we went to the main.py, let me just try to shift it here. Yeah, so we have classes. And so on the main, if we want to use the class called fruit, so now definitely we are just going to say from classes, import fruit. Yeah, fruit is our class. So that now we can create fruits. We can create fruits using this class. So that now I can say maybe my first fruit is an object of a fruit class, like that. So that, and you can see it is automatically asking for the name of the fruit. Let me say maybe this mango, and the size is maybe 600 grams. Perhaps let me just put some spaces there for clean code. Color, maybe it's yellow. Yellow. And the price is maybe cash, maybe 50.00, something like that. That is our first fruit. Let me also create the second fruit as well, maybe second fruit. Is an object of a fruit class, fruit. And maybe the second one is, let me say maybe this apple, and the weight is maybe 450 grams. Maybe the apple is pink, and maybe the price is cash, 40.00, maybe. Yeah. So that if I wanted to print anything on, so by the way, this first fruit and this second fruits, these are now the actual fruits. As a matter of fact, you can see we are saying first fruit is coming from a class called fruit. So it means I have to give this property in the exact order as the way we defined up here. Because if I just come here and I pick the price so that this price is the one that is starting at the beginning, I mean, that is not right. That is not right. Or if I add one more thing, like maybe say, maybe the description as maybe very good. This is wrong. Why? Because where are you getting this last property? Because when you defined your class, it only has these properties here. So if you add any, that's going to be wrong. Or you forget to add one, like assuming this last one, I didn't add that. I mean, this is going to be wrong. This class will not work. Yeah. And so it just has to be that. So that if at any time I want to just print maybe second fruit dot price. When I run this, what do you think is going to be the price? If you guessed 40, you're right. Yeah. And so quickly, we've already created a class called fruit. I mean, let's look at another example where we can define another class for maybe cars. And we said if we're creating a class for cars, then the class name starts with a capital name, but again, it has to be in singular. Yeah, class called car. Yeah, and you see, I'm creating it on just the same line. Like, yeah, I'm considering indentation very carefully, so we can have a def init function. Or again, remember, it's not int. Yeah, init, so that now a car can have maybe model. Okay, maybe model, maybe registration number, maybe color, maybe price. Okay, so let's say the car has those properties, then we can simply say now self dot model equals to model. Yeah, let me duplicate this and copy these properties. Self.regno equals to regno. Okay, let me duplicate this as well. Color, self.color equals to color. Okay, let me duplicate this as well. Self.price equals to price. Yeah, like that. So that now, right now, as a matter of fact, let me just format this text a little bit to put a few spaces so that it doesn't give me those warnings. Yeah. So now, right now, as a matter of fact, we have this class. So if I wanted to create a car out of this class, so definitely, I'll just make sure that first of all, I import the car up here. Yeah, the class car. So from classes, import fruit, comma, car. If I had more classes, I would put commas as well to import them, so that now I can say maybe my first car. First car is an object of a car class. And so you see, it's automatically asking for the model. Maybe this is a Prado. And maybe the registration number is KDA006J. And maybe the price is cash, maybe 16M. Let's say, okay. And let's have a second car as well. The second car, which is I can call this maybe is an object of a car class. And so now this car is maybe Mercedes, and maybe it is a KDJ, maybe 900 V, yeah, and maybe the color is gray. But wait, do you guys notice a mistake? So we needed to have a name, registration number, color. Did you see we have omitted something here in between here on the first one, even before we complete this one here? So let me just put a comma here in between. Let's have a color of this Prado. Maybe it's black. Yeah. So here the Mercedes is gray. And quickly right here, I can say now the price is cash. Cash maybe 3.8M. Yeah, maybe 3.8 what? M, like that. And this is working super cool. this is working super cool because now everything is working. So if I wanted to print, maybe print fast car dot maybe color. See, yeah, what do you think is going to be printed? If you guessed black, you guessed right. So if I just run this, look at that. I have black right down there. I have black right down there. Now look at this. Classes can also have functionalities, assuming this class called car has a functionality like maybe braking. Maybe this fast car can brake. Yeah. So quickly, let me just also on the same line as this fast def, let me define a brake function. Let me define a brake function, and automatically, you see, it is automatically going to give me a self keyword, because that's how I can access that. Then I can just simply print and say, yeah, I can brake. Yeah, I can brake. And maybe this car as well has an accelerate functionality. Yeah, maybe def, maybe accelerate functionality. And we can also just print and say, yeah, I can accelerate. Yeah, I can accelerate like that. And so bulb, everything looks good. Okay, so now our braking functionality and accelerate functionality are now on the car class. So that now if I just come to my main file and I try to access that functionality, if I just say maybe fast car dot accelerate. If I just run that, you see, it is going to tell me, yeah, I can accelerate because we can access that functionality. Yeah, I can even also say maybe second car dot brake, and you will see, yeah, I can brake. Yeah, I can brake. Everything is working super, super cool. Super, super cool. Now, right now, what if we had a functionality, say, maybe let's say we have a class for a student, and let's assume a student can be able to register and a student can be able to log in. Let's just do this quickly. Let's have a class. Let's just define a class. So we have software defined a class for a fruit, class for a car. So let's down here on the same line as of how we are creating the classes. So down here, so let's have a class for maybe student, like that. Then we can define an init function so that now this student has a property of a name, maybe email, and maybe password. Yeah. And so now once we do that, let's just say now self dot name equals to name. Okay. Alafu also let's have self dot email equals to email, and self dot password as well equals to password. Self dot password equals to password, like that. So everything is looking super cool. Let me just click on these underlines right here. Then it's gonna give me, it's gonna give me some bulb here. Yeah, I can just say reformat file, and yeah, it's just gonna add a few spacing right in the code to fix those underlines, but everything else looks good. So we have a class called student, but of course, we are going to be creating students out of this class, and every student should have a name, email, and password. But of course, the class starts with a capital letter and it's in singular. So now let's assume this student can register. Def, we can say maybe register function. Yeah, so this function, maybe we can just print and say, we can just print and say, you registered with email. We can put a self.email here. Yeah, self.email. You registered with email that. And then we can also say, and password. Then we can just put self.password, maybe. Yeah, self.password. Yeah. you registered. Maybe that's our register function. Yeah, when someone just accesses that register function, we tell them you registered with email. Then we say the email they will have entered as a property, and then the password they will have entered. Yeah. Okay. So maybe also the student can log in. Maybe so we can def a login function. And here we can even just assume. We can assume the student has already registered. I mean, it's not like we are implementing the actual registration code. Yeah, don't think we are doing that. So it's just some dummy code for us to understand the concept of classes. Yeah. So let's say maybe this functionality, we can just do an if statement and say if self dot email is maybe maybe abc at example .com. Maybe that's the email. Then we can say and self.password is 123. If that is the case, so if self.email equals to this and self.password equals to that, we can just print login successful. Login successful. Else we can print maybe wrong email or password. Wrong email or password, like that. Yes, wrong email or password. So let's assume the student can do this. And as a matter of fact, let's just try and see if we can create a student out of that. So let's say maybe first student equals to is an object out of a student class. But wait, we haven't imported that class yet. So here we can say student. Okay, great. So it's an object of a student class. And so the name, maybe let's say the name is Josh. And maybe the email is josh@gmail.com. And maybe the password is 123, maybe 45. So if I just try to access, say maybe first student, first student dot register, you will see it's just going to tell us that you registered with email Josh. Yeah, you registered with email josh@gmail and password 12345. If we try to access the login, so first student don't login, and you will see it's going to say wrong email or password. Wrong email or password. Why? Because we said if the email is, let me see, login. We said if the email is abc@gmail and the password is 123 is when we say login successful, otherwise wrong email. And so right now we have given the email, josh@gmail. But if we said abc@example, then the password we just say 123. Then this way is when we are going to have a successful login. Yeah, login successful. But otherwise, if we just revert it back to Josh, and you run it once again, you see wrong email or password. So now, as far as I'm concerned, right now we have a student class, and that student can be able to register. That student can be able to access the login functionality as well. Now, having said this, let's assume you are creating this system, but again, after you have designed the student class, yeah, after you've designed the student class, again, you are required to design a teacher class. Let's say maybe you have a class called teacher, yeah, class called teacher, but now you have a class called teacher, but now this teacher as well needs to be able to register and needs to be able to log in. Do you think we are just going to be copying these? Do you think we are going to be copying this register and login and put it to the teacher? No. So what the teacher class is going to do is, we are going to cause this teacher class to inherit login and register functionality, even together with the properties from the student, because the student can already be able to register and log in. And so we can just inherit those properties. And how to inherit those, you just say class teacher, but again, in brackets right here, you just say it is inheriting from a student, like that. And once you do that, that's super cool. I mean, it will have already inherited those properties from up above there. And so maybe a teacher can have, we can even say maybe you can add more functionalities for the teacher. Maybe a teacher can have more functionalities. You know, the student can only be able to register and log in. Maybe the teacher should be able to register, log in, and maybe submit results. Yeah, something like that. Maybe we can even define a submit underscore results function. Maybe a teacher can submit results, and so we can just print and say, yeah, I can submit results. Yeah, I can submit results. Yeah, I can submit results. So this underline here, let me just click on the ball, reformat this file. Ah, cool. Yeah, you guys can't be able to fix this. I mean, this underline here, I mean, just leave it as it is, okay? So now the teacher will be able to register and log in because the teacher is inheriting those from the student, and the teacher will do an extra functionality of submitting results. So that now if I just come down here and create a teacher, but of course, let me import a teacher class here. Yeah, so down here, if I just maybe say first teacher is an object of a teacher class. And the teacher, we can say maybe the teacher is king, and the email as well. Did you notice that we are being requested for the name and for the email and for the password, and yet those, the name, the email, and the password, we designed them on the student. You remember those up here? And yet the teacher class didn't even have the constructor class, but we are being requested for them. Yeah, if we don't put them, it won't work. It's because all those requests are coming from this student class up here. So now, quickly right here, so we have a first teacher is an object of a teacher class, and I can say maybe king@gmail.com, and then the password is maybe 123, something like that. So that down here, if I wanted to access a teacher, maybe teacher.register, you see, I can actually access that teacher functionality. I can also can say teacher.login. Maybe I can access a login functionality for the teacher. And also, as an extra functionality, we can say our first teacher dot maybe submit results. You see, our teacher can as well submit results. Our teacher can access the submit results functionality, which the student was not able to, which the student was not able to. So right now, as a matter of fact, we can say we have implemented the concept of inheritance, where a student has properties, and now the teacher is inheriting from the student. And by the way, we can even have another class as well, maybe say school principal, maybe the principal inheriting from the teacher. So the principal will be able to register, the principal will be able to log in, the principal will be able to submit results, and we can have the principal do one more functionality. Maybe say class principal is inheriting from a teacher class. So if the principal is inheriting from the teacher class, it means the principal will be able to do everything the teacher can be able to do. And remember, the teacher already is able to do what the student can do. And so here we can even just add more functionalities for the principal. We can say you can add more functionalities for the principal. Yeah, and so we can just quickly say, maybe I can just define maybe suspend teacher function. Yeah, maybe a principal can be able to suspend a teacher, but you see, a teacher cannot be able to suspend a fellow teacher. Yeah, and so quickly we can simply say now we can just print and say, yeah, I can suspend a teacher. Yeah, I can suspend a teacher. Yeah, I can suspend a teacher. Yeah, I can suspend a teacher, just like that. So quickly, if I just go to the main and maybe try to create a principal, maybe first principal is an object of a principal class. But wait, we haven't imported the principal up here. So principal, yeah. So is an object of a principal class. And so the principal also requires a name, which is maybe Falme right there. And maybe Falme at Gmail. And the password perhaps is 123 right there. So I can also say maybe principal principal dot maybe register. You see, the principal can be able to register, and the principal can as well be able to log in. And you see, the principal can as well be able to submit results, and the principal as well can be able to suspend a teacher. You see, all these properties, the principal can be able to access them because it is the concept of inheritance that is putting them at our disposal. So if I just run this, look at that. Yeah, the teacher can actually, the principal can actually be able to do all those. The principal can be able to log in, register, login, submit results, and suspend a teacher. Suspend a teacher. And so quickly, as you can see in our classes, we've just been able to define these classes, and we've also implemented the concept of inheritance. The concept of inheritance. So that's it about the concept of inheritance. I mean, object-oriented. And so because we are creating a class, like say fruit or car or whichever class that we've created, and when we come to this other side, when we are creating a car, like say or a fruit, if we are creating this fruit out of the fruit class, then we can say this is the object. This is the object. This is the actual fruit. As a matter of fact, this is the actual car that we are creating out of the car class. And as you can see, the actual car has a name, the actual car has a registration number, and so on and so forth. Yeah, this is our actual student. I mean, these are now the objects. Yeah, so this is our actual teacher. Yeah, these are actual principals. So these are objects. And so that's it for today with the concept of object-oriented programming. And let's see you in the next class, where we're going to use this concept in creating databases and creating tables in our databases and storing data on those databases. So having said that, bye-bye for now, and see you in our next lecture.